Let's say for some silly reason you need to practice welding stainless steel tube to stainless steel plate in the 5F position. How do you do that? You build one of these. Stand by. I recently had a test assessment at a local company, and that assessment consisted of a piece of flat stainless that had a hole punched in it, as well as a piece of tube, also stainless, and the assessment was to tack, fuse, and filler rod that tube to that sheet. You know, and I did okay. I don't have a lot of experience in welding, so this was kind of a stepping into the big leagues type of a thing. And the guy was very encouraging. He said, "Dude, you're close. You just need some more time." Given that, and that's encouraging to me, because again, as young as I am in this, for somebody to say that's not horrible. So in order to set myself up for success, what I want to do as best as I can is replicate the fixture that they had for me to hold this in, because that is another, it just adds another level of difficulty to it, is that you are doing it in a vertical position. And once you're able to tack it flat, but once you set it in the fixture, it stays in the fixture until he comes out and gets it. So what we're going to do is we're going to build our own fixture, because what good does it do me to practice the entire process flat if I'm not assessed on it in the flat position? I need to be able to do this in the position that I'm being assessed in. I have a local metal supplier, metal supermarkets, and the owners they're fantastic. Their employees are fantastic. They're great to work with. They help me out a lot. So I've been able to secure this 304 stainless sheet. I've been able to secure this 304 stainless 1/2-inch thin wall tubing, and what I have to do is I have to punch this hole in it. This is a 1/4-inch hole, because that's the way the plate came. Now there is a downside to the way that I have got to do this. What I have is one of those. Once again, friend of the channel Jay, cleaning out his garage full of stuff, came across 2 of these and kindly donated one to the cause over here. The only downside is my throat isn't quite 2 inches, so it doesn't get me quite into the center of this. But I think for our purposes, it's going to be close enough. Now I might even just go in and try to clean up the throat of this in here, and that might get me a little bit, but I don't think that's going to get me the whole distance. We may just mark it out and see how close we are. This will do a number on you too. This is not a kind and gentle process, but you work with what you got, and this is what we have, and we're very grateful to have what we have. So we've taken care of the source materials. Now there are 2 other things that we have to take care of. One is a positioning device, and we've kind of got that problem solved already. So what we're going to do is we're going to adapt this welding positioner that I made. We're just going to remove this piece, and then I have another piece that we're now going to be able to use as the basis for the head that we have to use to hold this piece in. One challenge that we get to do is we get to affixate this piece of perforated mesh, which is, as you can see, quite a bit thinner than the material it's getting welded to. So we get to work on our heat control. How can we get enough heat into this so that we melt the top of this and also melt the bottom of that. That's going to be kind of fun, because this is going to go over that hole like that, because the fixture that I was working on had backing gas on it. And in order for us to replicate as best we can the environment that they're going to test us in, we have to have backing gas. So I've secured a dual flow meter for my argon. We've got a piece of hose. So we're going to have this mesh on the front. The inside of it, we're going to fill up with a diffuser material, probably just going to use steel wool. I've got an abundance of that. Then we're going to cover the back of that. Again, we're using up as much scrap as we can. We're going to cut a plate out of this and then drill a hole in it, and then we're going to affixate a tube onto the back of it that we can put our argon hose on, so that we will have a complete fixture to get the backing gas through onto the back of that plate. Then to position that plate, this is where it gets even more good funner, is we're going to use these thin straps of metal, and we're going to concoct a way that these two straps are going to hold the coupon flush against here, which will look like that. And then this is going to hold the bottom of that coupon in place. So once we slide that coupon down in there, the two side straps hold it to here. This strap holds it in position, getting our hole as close as we can to the center here, again, to replicate the way that fixture is made. I expect this is going to take a couple of episodes, just because we're going to do a lot of stuff that we haven't done before. We're also going to be working with dissimilar metals. I have regular carbon steel here and here. I have some stainless steel components as well. We've secured some filler rod. We're going to use some 309 filler rod, which is, in theory, going to allow us to weld stainless steel to carbon steel. We'll see. We'll put some of this stuff to the test, stuff that I've never done before. So I have done I don't know what you want to call it, a proof of concept, maybe, and have fabricobbled up together this prototype, I guess you could say, because I've never welded regular steel to stainless steel. So that was something that I wanted to make sure that I could do it before I got too deep into this, and it worked fine. I used the 30L rod, and even with this kind of misfit edge that I had on here, it worked fine. I even did a lay wire right in there, and it laid down just fine. I had zero problems with it. This mesh, again, I just wanted to make sure that I was able to do it. This is the original piece. You'll notice that it has this big bar across the top. I ended up buying a strip of this, and they were nice enough at the metals place to cut one off for me, and then I cut another one off as well. So it's not that hard to do. Got this on first, stuffed it with the steel wool. The thing that I found is that I notice I'm lacking steel wool up here in the corners. So we're gonna have to kind of figure that out when we go to make the real one. You guys have got a lot of knowledge in your head about what you can and can't do, and I don't have that body of knowledge in my head right now. Okay, let's put some tack welds on. So basically, what I'm doing here is a bunch of little teeny tiny fusion welds. All right, so we've got this welded on. It's not too bad. there was something going on in this corner and in this corner as well. I had sputtering, and at first I thought maybe there was something weird going on with the cup, so I switched cups. I actually switched tungsten sizes and I switched cup styles. I went from a 1/16 tungsten stubby gas lens tin clear cup and went to a 3/32 gas lens number 6 cup. And it was, so I don't know if there was something funky on this metal or what. Now we get to do this. This is the thing I hate. I just don't know how many of these I can do without like pooping my pants or something. Because this is like a not fun thing to do. Now there is a little dimple on the end of this die that kind of helps things, at least getting you located in the hole. And I'm not kidding you, this is the way I've got to do it, because trying to punch a 1/4 inch hole, .04, I think it is. It works, but it ain't fun. Whew. Take your breath away. So now we get to weld this up. Tack weld. Now we'll do a fusion weld. I think that's all we're going to do. Now, the nice part, we haven't potato chipped this. I've taken a bunch of steel wool and pressed it down so that I made sure that I have got steel wool in my corners there, so I don't get any areas where I'm just getting a lot more flow than others. This is all just to diffuse the gas that's going to be coming in here through this tube. That was weird. That one side, it did not matter what I did to it. It just did not want to join up. So I think probably I had a gap in it. Right there. We will finish this out later because I was just informed that supper is here, and I'm gonna go eat now. So there is our, I don't know, fixture head, I guess you could call it. And I'm going to do it back here just because that's going to allow me a little more room up here in the front to put on the pieces to actually hold it. So like here. It's not going to be this long, but so I'll have enough room. I'll have more room to finagle around with if I push this to the back. All right, our next little bit of fabricating that we've got to do is we have got to come up with a way to fixate that hole in the general center of this backing fixture. Now I know I'm off, and the reason I'm off is because the throat on my hole whacker doesn't go in a full 2 inches. So I'm okay with that, and the reason that I'm okay with that is when we are able to fix this in position, I can weld this with this off-center one axis, and then the next piece I come in, and now I'm off-center on the next axis, off-center. So I have 4 different axes that I can be off-center with, and that's going to change up my positioning. And that is going to be more of a challenge, and I think that's something that that's something I need to do. I don't need to practice it dead nuts on every single time, because then I'm going to expect it to be dead nuts on in the same position every single time. So if I change it up, then that's going to force me to become a better welder by welding in 4 different positions, slightly different than the previous one, than just one all the time. So what we're going to do is, this is the position that I have to locate that in. And what I think I'm going to do is I've got these stainless strips. Overkill. Why are you using stainless? Because that's what I've got. Same thing here. These 2 are stainless, and I'm using that because that's what I've got. So what I'm proposing to do is to put an angle in the end of this, and then cut that off at that part, and then weld that right in along that area there. So nothing fancy, it's just a vise, and I've got my piece of sheet metal in there. And then I just use this piece of bar stock. So now I'm going to use this so that I can tighten that radius up. So as I'm sitting here thinking, which happens on occasion, my mind is going, if I weld this like that, and I'm adjusting this back and forth, that's going to put a lot of stress and a lot of strain on that one little thin joint. So now I think I'm going to make a midstream correction here, and we're going to make a retainer like this. And this way I can weld here to get this nicely affixated, get it adjusted into the position that I need by bending this however I need to. And then once we're in a really good spot, if I want to, I can continue to weld that up until this adjustability point. All right, so we're tacked up there. I don't know what's going on. I've cleaned this. Perhaps that's just mill scale that I didn't get this far down. It's pretty schmutzy coming off of there. It likes to pop. And you know, that's never fun. So we're fixated there, nice and tight against that backing plate. It'll slide down there like that. Now, the fun part is going to be here, because I got kind of a short space to work with. What we'll do is we'll run a short length, then we'll bend a 90 to come up, and then we'll bend another 90 over. All right, hey, that's not bad. All right. So I'm going to give this a nice scrubbing and see if all these pieces, we're going to scrub them down real good. May even clean them with some acetone just to see if we can get that popping and spitting to go away, because I don't know why that's doing that. I have zero breeze in my shop. All the windows are closed. I don't have any of the air handlers on. The only thing that I've got, there's the welder over there, and you'll notice that I've got this piece of board over here because I have a vent right here, and it will blow right. I mean, you can see this. You can see that cloth moving. So I put this little board right up there, and that's going to deflect it 90 out, takes all the velocity out of it, so it shouldn't be an issue. I'm going to say that mill scale was what was causing all of our popping and cracking, because we didn't have hardly any of it. We did have a little bit, and that's because I stuck my electrode, because I'm welding on this side with my non-dominant hand. But that's a good skill to have. So instead of repositioning all this stuff so that I could do both of them with with my dominant hand, you do one with, and you do one without. And you know, if I'm honest, that's probably the way we should weld it up too, just to get some practice doing it, holding it with this hand. So what we now have is, we have this welded up. Now, I've got one not very pretty weld right there, but that was in a weird position, and you know, something that I just thought I would try, and learned a lot from it. Changed the tungsten, and now our beads got much gooder. Same thing over on this other side. I decided not to do this end. Figure we're probably going to be okay. And then we got some actually nice and pretty. Actually got some, that's kind of weird color, because this is stainless, but this is carbon. So this is the 309L that we used on this. So I'm sure that's why we're getting that color on there. So what we're going to be able to do now is, once we have tack welded our piece on, we can then put it in this fixture. It does two things. It's going to give us backing gas to keep the back side of that weld from sugaring up and getting too hot, and then that also locates us in that fixed position that the weld assessment wants us to be in. Are we going to weld in that position? I don't know. Is it more about trying to see what we can do with heat control and working in odd positions? Yeah, there we go. So here we are in the holder. Remember, we made this holder when we were originally making this fixture welding clamp dealio. And so now argon goes into here, gets diffused through here, comes out the front to back our weld. We can then, this again, you spot weld this in a flat position, but then you put it in like this, and then you get to weld this. You do a fusion weld, and then you can do a filler weld on there. And why did I do this? Because this is part of the assessment for the place that I would like to work someday. And you fight like you train. It doesn't do me any good to weld this in a flat position because they're not going to test me on that. So anyways, let's see if I can pull this off without killing myself. So anyways, there it is. It's just a positioning holder, a backing fixture, and a position fixture that we made with mostly stuff we found in the shop. What did we have to buy? We bought that piece of screen, and we bought some 309L filler wire. Anyways, if I can do it, you can do it. I'm James, this is Rattlecan Fab Shop. You guys have a good one. Cheers. I hope you found this episode educational or entertaining, or maybe even both. You might want to check this one out as well. Be sure to hit the subscribe button, hit the little bell to be notified when new videos drop, and if you got comments, make sure you put them down beneath the sermon notes. Thanks for hanging out with us here at the Rattlecan Fab Shop. Y'all have a good one. Cheers.